Good day everyone, I am Arturo C. Cruz Jr. from BAIT1A. For today's video, I will discuss to all of you the Fibonacci sequence. Before we talk about the definition of Fibonacci sequence, let me introduce you first the name behind the Fibonacci sequence. He is Leonardo Pisano Fibonacci. Let's get to know him more. Leonardo Pisano Fibonacci is also known by his nickname Fibonacci. He was born in 1170 on Pisa, now Italy, and died on 1250. He is the son of Guglielmo and a member of the Bonacci family. In addition to his own considerable achievements, Leonardo of Pisa, also known as Fibonacci, played a key role in resurrecting classical mathematics. Liber Abaci introduced Arabic numbers and the Hindu-Arabic place-value decimal system to Europe. Now we know who Leonardo Pisano Fibonacci is, we can now proceed to the definition of Fibonacci sequence. The Fibonacci sequence, often known as the Fibonacci numbers, is a set of integers that begins with a 0, is followed by a 1, another 1, and then a string of numbers that increase rapidly. Each number is equal to the sum of the two numbers before it in the series.
Let's take a look at the sequence. 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. With the use of Fibonacci sequence, we will start with number 1, then followed by another 1. To get the next number, we will follow the rule of Fibonacci sequence, which is add the two preceding numbers, so 1 plus 1 is equal to 2. Then add again the two preceding numbers, so 1 plus 2 is equal to 3. Then just continue until you reach the term you wanted. And that's how Fibonacci sequence work. Aside from that, we can use this formula to get the term we wanted more quick and easy.
Let's have some examples for you to understand more the Fibonacci sequence.
Example 1. Find F13. To find the F13, we will use this formula. Then the next step is substitute the value of n, which is 13 because we want to find the 13th term. So it goes like this. Then the next step is we will find the answer in this part. So the equation is now 521 minus 0 divided by the square root of 5, and it is equal to 232.99, but we will round it off to get the exact value, which is 233. So the 13th term is equal to 233. Example 2. Find F18. To find the F18, we will use this formula. Then the next step is substitute the value of n, which is 18, because we want to find the 18th term. So it goes like this. Then the next step is we will find the answer in this part first. So the equation is now 5778 minus 0 divided by the square root of 5, and it is equal to 2584. So the 18th term is equal to 2584. And now, let's talk about how Fibonacci apply in our life and in our nature.
Most of us probably haven't ever taken the time to thoroughly consider the quantity or arrangement of petals on a flower. If we did, we would discover that the number of petals on a flower that still has every petal and has not lost any is a Fibonacci number for many flowers. For example,
the white calla lily has 1 petal, iris has 3 petals, buttercup has 5 petals, delphiniums has 8 petals, marigold has 13 petals, aster has 21 petals, pyrethrum has 34 petals, and Michaelmas daisies has 55 petals. It somehow follows the role of Fibonacci sequence. Also, the measurements of our bone in finger and hands follows the role of Fibonacci sequence. Lastly, the Fibonacci spiral looks like an eye of a storm and the cochlea of our inner ear.
And that concludes my discussion regarding the Fibonacci sequence. Hope you learned from me, and thanks for watching.